Hello, today we're going over measures of spread, talking about the center and shape of data. We're also going to be talking about quartiles in the inner quartile range. First thing I'd like for you to do is to take a look at this paper. What it's showing you is how different graphs can look, whether they're symmetrical or not. And I wanted to remind you that if we have, for symmetrical, what that means is if I had a shape like a heart and I were to fold it in half, both sides would be the same. So symmetrical means if you were to fold something in half, either side along the crease of it would be identical. So these right here, these four, all show what a symmetrical graph would look like. Notice right here, this is the tallest, and then these two are even. This is even. The size of this quartile is even to the size of this quartile. This quartile is even to the size of this quartile. In the bar graph, or I'm sorry, the histogram. In the histogram, this is symmetrical, the same amount on either side. The stem and leaf plot, also symmetrical in the shape of it. So these have 5, these have 3, and this has 5. So it's symmetrical going this way. And if you can't tell, you can draw lines on the graphs so you can see that they're all symmetrical. Over here, these are asymmetrical. That means the ones over here are asymmetrical, which means not symmetrical. You'll see that if I draw the lines on top, that they're not symmetrical to each other. That this side is less than this side is less than this side. So that then we also have something called skewed. And what skewed is, I'll show you. Skewed means when data has a long tail on one side or the other, so it's not symmetrical. So like by long tail, it means a lower side that is the lower than the mean. So the mean is always usually at the peak when it's skewed. So looking back at our paper, we can see that this is skewed left, right, and right. And what that means is that the tail end is on the left, so the side of the tail tells you the direction of the skew. These might be a little more challenging to see. You might see them better down here. So this is skewed left because the left side is your low side. This is skewed right because the tail is on the low side, which is your right. So if I were to turn these graphs and I were to draw my line, the tail end here is on the left, the tail end here is on the right. So on stem and leaf plots, you have to turn it to see better. So that is some information on the shapes and what skewed means. It just means there's more data on one side compared to the other. So put that paper to the side for now. We'll use that when we start to glue. Look at this paper. So this is what you should have written. Pause if you need to. Okay, so going to the other paper, the one that says notes, we're going to be talking more about quartiles. So measures of spread are used to describe the distribution or spread of the data. So that means how is it distributed? How is it laid out? What is the mean? What is the median? What is the quartiles of it? So the range is the difference between the greatest and the least. We've already done that. So greatest minus least. The quartiles, right here, quartiles are values that divide the data into 4 equal parts. So quart, like a quarter, there's 4 quarters in a dollar. So the quartile divides it into 4 parts. Circle those, please. The median of the lower half is called your first quartile. The median of the upper half is called your third quartile. And the difference, so that means subtraction, between the third and first quartile is called your interquartile range. Interquartile range. We call that the IQR. The first quartile we call Q1, and third we call Q3. As you do more of these, it'll make more sense. So it says determine the measures of spread for the number of votes received for student government president. So those are our values. So The greatest number in the data set is 21. The least number is 2. So the range is 21 minus 2, or 19 votes. Your range is 19 because we took the largest minus the smallest. That's your range. Now, to determine your quartiles, put the numbers in order from least to greatest. So we took these numbers and put them in order from least to greatest. So what we need to do now is we find our median, and we find our median by crossing off until we get to the middle. So our median is 15. Now to find the median of the lower half, I like to cross the opposite way so I can tell. So I cross here, 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 here. Q1 is 12. So I'll do the same thing on the upper half. Cross here and here. So Q3 is 18. Your third quartile is 18. To find your interquartile range, your IQR, we subtract the 12 minus 18 and we get 6. So IQR is 6. So we're breaking this into 4 parts. So I'll show you at the bottom. I'm going to rewrite it. So we have 2, 10, and so on. Like we did with the median before, if you have 2 numbers that are your median, you have to find the mean or the average. So add them together and divide by 2. So we're saying there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So your median is here. Your 15 is your median. And then we are breaking this into 4 pieces. So if I were to divide this half in half, it would be my 12 would be the middle. And then this half of the line in half would be 18, this 18. So we're breaking it into 4 pieces. So we have 2 here, 2 here, 2 here, 2 here. So 4 pieces. 1, 2, 3, 4. So the quartiles break it into 4s. We have something called an outlier. An outlier is a data value that is either much greater or much less than the median. Outliers are more than 1.5 times the value of the interquartile range beyond the quartiles. So what that's saying is an outlier is a really small or really large number. So it doesn't go along with the other numbers that are there. An example, we'll get to that in a minute. So a gap is a space between the set of data. So it's an interval. So there's a large space in between 2 and 10. That's 10 minus 2 is 8. There are 8 numbers missing there. Everything else has a relatively small one. We have a couple gaps between 18 and 20, between 15 and 17, and 10 and 12. A cluster is data that are grouped closely together. So this whole area minus the 2 would be a cluster. These features are easiest to see when graphed as dot plots, box plots, and stem and leaf plots. You can see those 3, outliers, gaps, and clusters, much simpler on the graphs. So up here it says, determine any outliers for the set of data given in example 1. Think of a number or numbers that stick out on their own. So your outlier for this data would be 2, because 2 is much, much, much smaller than the next numbers. So we're going to now do some practice. So we need to find our range, median, lower quartile, upper quartile, the interquartile range, and the outliers. First thing I need to do is put these numbers in order from least to greatest. And I like to cross them off so I don't get confused and write one more than once. Okay, so they're in order from least to greatest. Now we need to find the range. Remember, the range is the largest minus the smallest, greatest minus least. So the range, we're going to do 51 minus 14. So 37 is your range. Your median is your middle, so cross off until we get to the middle. So that's my middle. My median is 28. Your lower quartile is going to be the median of the lower side. So I cross the opposite way so I don't get confused. So my Q1, my lower quartile, is going to be 19. My upper quartile, find the middle, is going to be 30. So what I did was I found the middle of the low part and the middle of the high part. Now, in order to find the interquartile range, you subtract your two quartiles. So we do 30 minus 19, we'll get 11. So your interquartile range is 11. And now an outlier is a number that's significantly farther than everything. So that's going to be 51. 51 is much higher than the rest of the numbers. That problem's finished. Let's try it again with these problems. First thing we need to do is put these numbers in order from least to greatest. So 65. And then 88. 2 88s. 89. 91. 91. 92, 93. 95. And you can count to make sure you have the right amount of numbers. So let's find the range. So biggest minus smallest. So 95 minus 65 is 30. Your range is 30. That means it goes across 30 numbers. Your median is your middle. So cross off until you get to the middle, one on each side. Your median is 91. Q1 is the median of the lower half. So now we have 2. Well, since they're both 88, what you would do is add them together and divide by 2, but since they're both 88, your Q1 would be 88. Can't be anything else. Now let's do it with the upper half. So it's going to fall between 92 and 93. So we have to find the average of 92 and 93, or what number falls between. So we add them together and then divide by 2. And we get 92.5 as my Q3. And then my interquartile range is subtracting the 2. So 92.5 minus 88. Line up your decimals. You get 4.5. And then the outlier is a number that's significantly lower or significantly higher, and that would be 65 because there's a gap between 65 and 88. So an outlier would be 65. When you're finished with that, fold in half. Do the same routine that we always do. Fold that in half. Fold the other paper in half, and if you want to do it so that you can see. Then we're going to glue both of those into our notebooks right after our mean, median, mode, and range. The one on each page. And I'm gluing this one in first. Go ahead, glue. So these are both glued in there. And I know some of you like to just look at the papers completely finished, so I'll allow you to see this, and then you could pause so you know what to write. So now both of these are in there. Pause this screen so you know what to write here. Now on today's paper, you're going to do the same thing we just did. Use your notes to answer these questions. There's a backup also. That's all.